Trigonometry, lesson 6.6, sinusoidal curve fitting. I'm not going to lie, I enjoy this. Remember our equation from earlier, y equals a, we'll use sine, we could use cosine, b theta minus h plus k. Let's go start figuring out the values here. Got to find the center line first. Now, a lot of people do this. 8, therefore it's 4. 1, 2, 3, 4. They draw that in. This is not a bad idea, but I'm going to be a little more precise. I'm going to find the average of -2 plus -6, because that's as low as it goes. So we find the peak and the valley on the y-axis, and it is not -1, 2. It's -1. And I went up 4 places, so I got -3. -1 plus, it's not -6 either, -5. -6 over 2, -3. That's my k. How far up and down do we go from there? -1 minus 3 minus -3, or we could have done, -1 minus -3, absolute value. Or we could have done -5 minus -3, and either way we get 2. That's our amplitude. Positive or negative, we'll come back to that. Cool. How about the period? Tricky. The period I'm going to slap it down here beneath. Period equals 2 pi over b. And I always go from peak to peak. This one looks a little bit off. It's not lining up perfectly. So let's give our best shot. This is 5, that's like 4.75. Minus what looks like 1.6. So, busting out my calculator here, I get about 3.15. You know what? I think the period was pi. I set that equal to 2 pi over b. Do a little cross multiplying, cancel the pi's. B pi equals 2 pi. B equals 2. So that comes from the period. What's left? Horizontal shift. All right, well, we're doing sine. We've got lots of options. I can slap a negative out front if I want to put the starting point here, or I can leave it as positive if I want to put the starting point here. I think I'll just put the starting point here. Why mess with a negative? So this is the horizontal shift. It looks like about, k is about 0. Well, we're going to the right. Negative 0.7, about 8. I'm going to go on my calculator and multiply that by pi and see if I get a nice number. I got 2.5. Let's see if that's pi over. .628 is pi over 5. It looks really, really close to pi over 4. By the way, normally we would not be using these, but I made this with pi, so I thought I might as well do it. So let's put it right in the middle. Need a new color. Running out. Purple. Y equals 2 sine 2 theta minus pi over 4 minus 3. And then I would always test it to see if it works. So that's it. That's how we curve fit. Well, what if we wanted to do a different trig function? Let's say this was cosine. Nothing has changed. Cosine, we want to start up here. Well, we kind of already figured that out. That's 1.57. That's pi over 2. So cosine, my k value is equal to negative pi over 2, just like 1.57. So nothing's changed. Y equals 2 cosine 2 theta minus pi over 2 minus 3. That's it. You might have noticed that's half the period. All right. Period was pi. It's actually 1/4, but that's a long story. And that's pi over 2. And this is pi over 4. So you're looking at shifting it over by pi over 4, and that's because in a real, these are shifted over by pi over 2. So, if you can make sense of that, good for you. Purpose of mathematics is to model things. What sinusoidal things can we model? Tides, temperature, weather, daylight, anything that cycles. So students in my class are now going to do a curve fitting project where they map a curve directly to map a set of data to a curve. Use some technology, use it by hand, use some more technology. It's a pretty cool project. So remember what we did here, and you should be good to go. That's it. Short lesson today. Hallelujah. As in all things, happy mathing.